Okay, well now we're going to move into the next part of Module 1.1 where we deal with quantitative data and the different ways that we can organize quantitative data. If you recall really quickly, quantitative data is data that is made up of counts or measurements. And so quantitative data by its nature is numerical. And quantitative variables can take on many different kinds of values. In creating a distribution for these values, you first must look at some vocabulary. So first off is the word class. The problem with quantitative data is it doesn't necessarily fall into a set category. Each data value is a number, and so we have to figure out a way to organize these numbers into categories. And so instead of categories, we put them into classes. On our previous slideshow, we looked at data that involved housing of college students. And so there are some natural categories that they could fall into. But what natural category does the number 84 fall into? Right? There's no category until we've created it. And so the class is the subgroup to which our data is going to fall. One of the key things you want to make sure is that your subgroups all have equal width. If they don't have equal width, then we have a problem, because those particular classes that have a larger width would also carry with them a greater probability that certain numbers would fall into them because they're larger. So we have to create our classes, and then once we've created those classes, we're going to go through our data and we're going to figure out how many fall into each class that we have. Now, each class that we have must have a lowest class limit, which is the smallest value that can belong in that class, and we must have an upper class limit, which would be the largest value that would belong to that class. So in approaching a large set of data that we have, and in wanting to figure out a way to classify it and to create these groups for them to fall into, we first want to get an idea of how many groups we want to divide our data up into. Usually those numbers are going to be somewhere between 5 and 10. We don't want them to be too small, but generally we also don't want to have too many classes. So depending on how much data you have, we decide ahead of time how many classes we think we should put these data values into. We also want to choose an appropriate class width. To figure out how wide each class should be, the first step is to get an idea of the general range of your numbers. And so if we subtract the highest number from the lowest, that actually gives us the range of our number. Then if we divide that range by the number of classes that we want, that gives us an idea of how wide each of those classes should be. Now typically when we divide our range by the number of classes, we're not going to get a number that's nice to work with. So we tend to look at and choose something, or we round that result we get to something sensible like 10 or 5 or 20 or 100, something that's easy to work with. Try to avoid widths that would be like 7 or 3, right? Those, though there's nothing wrong with that, they just tend to be harder to work with. And then after we've decided on how many classes we are and how wide they should be, then we want to find our class limits. Sorry. I'm looking at my notes here and trying to talk at the same time. So hopefully I'll get better at this as we go. So we establish what our class limits are, and then we go through and we systematically go through our numbers, putting them into their appropriate classes. So let's look at an example. Here I have some plasma screen TV prices from a few years ago. You can see they're a lot more than they tended to be, but it seems like there's actually, if I go into Costco, there's still TVs that are more than these values. So here we have them. So first of all, we want to decide on the number of classes. Now for this set of data, we're going to have 5. And since there's only 20 of them, that would put 4 in each category if they were spread out in a uniform manner. So that seems appropriate. We're going to just pick 5, the lower end. And number 2, we decide on our class width. So we'll take our highest price, which is $19.99, and we'll subtract the lowest price, which is down here, $15.95, and we get 404. That gives us the width of my overall data set. Then we divide by the number of classes we wanted, which was 5, and that gives me 81. And so I round that to a sensible 100, because 100 is easy to figure out. Now, once I've done that, we go ahead and we're not going to do it on the board. We're going to do it here. Now, we put those first into a frequency distribution chart. So, for example, for this data, I went ahead and went from 1500 to 1599. Now, if you'll notice, we decided on a class width of 100. So 1500 to 1599 actually is a width of 100. Because we're starting at 1500, which is really, if you look at the last digit, is a 0 number. And so if you were to count out 1500 through 1599, you would start with 1500 as your 1, 1501 as your second, so on and so forth. This can make sense if you think of the number of digits we have. Digits go from 0 to 9, right? There are 10 different digits, and they go from 0 to 9. 0 is the first digit, 1 is the second digit, so on and so forth. You count those out on your fingers, you end up with 10 digits. So we went from 1500 to 1599, 1600 to 1699. So as I'm listing these, 1500 to 1599, that is my first class, lower class limit being 1500, upper class limit being 1599. And I picked those because basically it puts them into the 1500, 1600, 1700, 1800, and 1900 categories, which is going to be easy. Once I've gone through and figured out the frequency of each, we're going to create a histogram, which is what our next thing here is. A histogram puts our data into graphical form. So remember, you have your frequency distribution chart, which is, we also saw that in the previous example. And then we have a histogram, or a histogram is what we're putting it into here. Now, a histogram is very similar to a bar graph. It has a horizontal axis, but in this case, our horizontal axis is an actual real number line. Previously, our horizontal axis was made up of categories. And those categories did not have any kind of numerical lowest to highest. Here, we actually have a real number line on our horizontal axis. And so we treat it as such. The vertical axis is the number of frequencies. And the width of each bars actually have meaning in histogram. The width of the bars represents my class width. And another thing that makes this different than a bar chart is that the bars actually touch. Reason being is that our upper class boundary is only 1 unit away from my lower class boundary. And so really, they're back to back. There's no gap in between them. Now, in here you're going to see the class midpoint is used to describe the each bar. You'll see this on the next slide. You could also use on either end of each bar the boundaries. And the easiest way to do is just to use your lower class boundaries at each end of the bar. I'll show you in this picture here. So here's our histogram. You can see that I've labeled each with the midpoint. Now the midpoint is helpful because once we've put these numbers into the histogram, we have no idea what the individual numbers were. They kind of get lost in these bars. And so if I do not have access to the original data, this midpoint is an estimate of the values within this category. Now, how did we get this number? Well, this number is actually the average of my lower class boundary and my upper class boundary. If you add 1500 plus 1599 and divided those by 2, you get this number right here. This is our midpoint. Another way to label this is to have put 1500 here, and then the next lower class boundary here, which would be 1600, and then 17, and then 18, and then 19, and then even though we didn't have anything in the 2000s, the 2000 would represent what would be the next class. In PowerPoint, the only way I could label these was with the midpoint. There was no way for me to do it on either end, and so we're doing the alternative, which is to label it with the midpoint. Now, labeling it with the midpoint, if you'll notice, I put the number right in the middle of the bar, and that's the appropriate way to do that if you are using the midpoint to label your histogram. If you want to label it the other way, you would want to put the 1500 in this location, and then the 1600 right here at the next lower class spot, and then 17, and then 18, and then 19, and 2000. All right, so here's an activity for you to practice. Create a distribution table of these scores using 5 classes, and then to display your results in a frequency histogram. You may want to hit pause and go ahead and do that.